Hey everyone, Pfizer here. Cybersecurity is more important than ever. It's not just about protecting our data, it's about protecting our privacy and our digital lives. And honestly, there's no better way to learn than by actually. In this video, we're diving into some cool cybersecurity projects that'll boost your skills and give you a real-world understanding of how cybersecurity works. We're talking about getting your hands dirty with code, dissecting real-world threats, and maybe even building your own security tools. Alright, let's kick things off with something that sounds a little bit, well, keylogging. It's got a bit of a bad rap, and for good reason. Imagine someone having a secret log of every single thing you type on your keyboard. Passwords, credit card info, embarrassing messages. It'd be a goldmine for any bad actor. That's the malicious side. But here's the twist. Keylogging can also be used for good. Think about parental control software that monitors what kids are typing to protect them online. The tech itself isn't inherently good or bad. It's all about how it's used. So how does it actually? A keylogger is a piece of software or hardware that records every single keystroke you make. Understanding how keylogging works is crucial in today's digital landscape. Let's take a trip back in time, all the way to ancient Rome. No, we're not talking gladiators and chariots, but something equally as cool, the Caesar cipher. It's one of the oldest and simplest encryption methods ever devised, used by Julius Caesar himself to protect military communications. Imagine this. You're Caesar, leading your legions into battle, and you need to send a secret message to your generals. You use the Caesar cipher, which shifts each letter in your message a certain number of places down the alphabet. For example, if you shift everything by 3 places, A becomes D, B becomes E, and so on. Now, to decode the message, all you need to know is the shift number. Building a Caesar cipher decoder is a fun and easy project that'll teach you the basic principles of encryption and decryption. You can write a simple program in Python, or even use online tools to create your own decoder. By building a Caesar cipher decoder, you'll gain a hands-on understanding of how this ancient encryption method worked and why it's no longer secure in today's world. We're all used to encrypting text messages and emails, but what about images? In a world where we're constantly sharing photos and videos online, protecting our visual data is more important than ever. Image encryption comes into play by scrambling the pixels in an image, making it completely unreadable without the proper decryption key. It's like turning your photos into a digital jigsaw puzzle that only someone with the right pieces can solve. There are tons of different methods used to encrypt images, from simple techniques like XOR encryption to more complex algorithms like AES. Now you might be thinking, this sounds complicated. Is image encryption something I can even do? And the answer is absolutely. There are plenty of online tools and software libraries that make it easy to encrypt and decrypt images. By exploring the world of image encryption, you'll gain valuable skills in cryptography and data security. And who knows, maybe you'll even discover a new passion for digital image processing along the way. Buckle up, we're diving into network traffic analysis and packet sniffing. Every time you visit a website or send an email, your data travels in small packets. Packet sniffing captures these packets and examines their contents. It can be invasive. In the wrong hands, it can steal sensitive information like passwords and credit card numbers. But it's also crucial for network security professionals to detect intrusions and vulnerabilities. They use tools like Wireshark to capture and analyze traffic in real time. Packet sniffing on your own network with consent is generally legal, but doing it without permission is a big no-no. Understanding packet sniffing helps protect against threats and opens doors to network security careers. Let's be real, the internet can be a dangerous place. Clicking on the wrong link, downloading a shady file, or even visiting a compromised website can infect your computer with nasty malware. That's where the Malware Analysis Sandbox swoops in to save the day. Instead of risking your entire system, you can open it in a sandbox. Think of it like a digital quarantine zone, a completely isolated environment where you can run suspicious files and programs without them affecting your actual computer. A sandbox is basically a virtual machine, a computer within a computer that's completely isolated from your main operating system. Any malware that runs inside the sandbox is trapped, unable to escape and cause any real damage. Security researchers and analysts use sandboxes all the time to dissect malware, understand how it works, and develop ways to detect and neutralize it. There are plenty of free and paid sandbox programs available online, making it easier than ever to protect yourself from digital threats. Let's talk about websites for a second. Behind the sleek designs lies a complex world of databases and code. Sometimes there are vulnerabilities that hackers can exploit. One such vulnerability is called SQL injection. Imagine logging in or filling out a form. You hit submit and a hacker intercepts that data. By injecting malicious SQL code into the database query, hackers can manipulate queries, revealing sensitive information. They can steal data, delete files, or take down the website. Developers can use input validation and parameterized queries to secure websites. Understanding SQL injection is crucial for developers and users. Alright, let's be real, nobody likes dealing with viruses. In the real world, we have vaccines and immune systems to protect us. In the digital world, we have antivirus software. It's your first line of defense against the never-ending onslaught of malware, like a digital bodyguard for your computer. But how does antivirus software actually work? It's constantly scanning your system for suspicious files, programs, and activities. Think of it like a security guard patrolling a building, looking for anything out of place. Antivirus programs have a vast library of known malware signatures, like a database of mugshots for digital threats. If it encounters a file that matches a known threat, it immediately quarantines or deletes it, preventing it from causing any harm. Many programs come with features like web protection, which block you from visiting malicious websites in the first place. New threats are emerging all the time, and even the best antivirus can't catch everything. That's why it's crucial to stay informed, practice safe browsing habits, and keep your software up to date. Let's talk about encryption, the backbone of cybersecurity. It's the process of transforming information into an unreadable format, protecting it from unauthorized access. And at the heart of encryption lie cryptographic algorithms, the secret codes of the digital age. Think of cryptographic algorithms like complex mathematical formulas that scramble your data, turning it into an indecipherable mess. Only someone with the correct key can unlock the encryption and access the original information. There are tons of different cryptographic algorithms out there, each with its own strengths and weaknesses. One of the most widely used algorithms is AES, or Advanced Encryption Standard, which is used to protect everything from online banking transactions to government secrets. Then you have asymmetric encryption algorithms like RSA, which use a pair of keys, a public key to encrypt the message and a private key to decrypt it. Cryptographic algorithms are the unsung heroes of the digital world, silently working behind the scenes to protect our data and ensure our privacy. By understanding how they work, we can make more informed decisions about our online security. Let's face it, finding vulnerabilities in a system is like finding a needle in a haystack. That's where security scanners come in, acting like X-ray vision for your systems, uncovering hidden weaknesses and potential entry points for attackers. Think of security scanners like digital detectives, meticulously combing through your networks, systems, and applications, looking for any signs of trouble. They use a variety of techniques like port scanning, vulnerability scanning, and penetration testing to identify and exploit weaknesses. Port scanning is like checking all the doors and windows of a building, looking for any that are left unlocked. Vulnerability scanning goes a step further, probing for known weaknesses in software and configurations. And then you have penetration testing, the ethical hacking of cybersecurity. It's like hiring a professional thief to break into your house to see if they can, all to identify and fix vulnerabilities before the bad guys find them. There are tons of different security scanners available, from free open source tools to enterprise-grade solutions. Regular security scans are crucial for maintaining a strong security posture. So there you have it, 9 awesome cybersecurity projects that'll take your skills to the next level. We've covered everything from deciphering ancient codes to dissecting modern malware. Remember, cybersecurity is an ongoing journey, not a destination. The more you learn, the better equipped you'll be to navigate the ever-evolving digital landscape. So what are you waiting for? Dive in, get your hands dirty, and most importantly, have fun. Stay safe out there, and I'll catch you in the next one.